these are the extra assignments past the review sheet. And like I was telling y'all earlier, and you all okay, so you have the review sheet. You can find the answers to the review sheet online. You just go to my website, PreCal Honors, Analytical Trig, and then it says some sort of review sheet answers. And so you have that as an option. Another way that I want y'all for you to review would be these items here in the textbook. So what we're going to do in the next few minutes here is that we're going to be talking about the evens off of this assignment, the evens off of this textbook assignment, just so you have a chance to see those, and it's just a chance to see something new and not the same stuff over and over again. Okay, so here's the topic list we're talking about. Simplifying and verifying trig identities. It's like making one side look like the other. And these are the 5 topics that are going to be on the test on Tuesday. Simplifying and verifying. Solving for trig. Remember, the directions for solving for trig are always from 0 to 2 pi. So you're using your unit circle on that. And then sum and difference identities. And then these are triangles, the log sines, and cosines. And we're actually not going to start here because you just send in your worksheet about log sines and cosines. So, let's start. I'm going to have to start with the textbook. Yeah. Alright, so let's start in the textbook. So we're going to start on page 530. So for even, did anybody have any in the first section, the 1 through 22? Did anyone see any or try to start any? Or you just want to pick a few random ones and just go for it? Number 12 and 14, yeah, that's good. Okay, let's do 12 and 14. Alright, what I'm seeing in both of those, so if you don't have a text in front of you, it's what? All over cosine x, sine y. And we're trying to make it look like cotangent minus tangent of x. Doesn't matter. So tangent y minus tangent of x. Okay, so what I would do is look at the top there, and I always kind of do that, like whenever I see one of these problems, especially the verifying ones. You can like work off of either side. You can work off the left side or the right side. So if you're never back and just like pause and just kind of study for a second and see which one. See which one might be easiest to work with, which one you can work forwards with. Does anyone have a suggestion yet? Because I think I see one, but I haven't had any issues starting with it. Off of what? Very good. So she said do the sum and difference. She said do the sum and difference identity off of that cosine x plus y. Alright, so if I remember correctly, the cosine equation is cosine of the first, cosine of the second. And then the signs are opposite, aren't they, in cosine? So since plus will be minus sine of the first, sine of the second. And that's all over the cosine of x sine of y. Okay, now what I'm going to do now is I have a binomial on top, and a part of me wants to like, alright, watch this. This is wrong. What I'm about to do is wrong, but a part of me wants to do that. You got like cosine of x over cosine of x, and then sine of y over sine of y. I can't do that because that top part is like stuck in a binomial. You can figure that to be stuff like that. So you may have any suggestions for the next step, maybe for rewriting this. Suggestions for rewriting this? So just because the same way that you know how to distribute through parentheses, you can distribute from underneath the parentheses as well. So I'm going to distribute the same thing. So I'm going to let this say cosine of x, cosine of y, and give it the denominator, minus sine of x, sine of y, same thing, give it the denominator as well. You see how I just distributed the denominator? It wasn't really like the same thing as, actually it was, the same thing as distributing through parentheses. Now it's 1. Except we're doing it from below in the bottom of fraction. So then now because it's one complete fraction, now you can let that cancel. And now you can let that cancel. So you're left with cosine over sine. your quotient identities. Cosine over sine, tangent of y minus sine over cosine, tangent of x. That's what you're looking for. Alright, so back at 14, we're still verifying to make these two identities look like, make these two sides look the same. We decided here, in the whole Senate of South Carolina, that we're going to use the sum of difference identity. So if you apply the sum of difference identities, someone kind of read behind me, like I said, I don't have an identity sheet in front of me. I think it's sine of the first, cosine of the second, plus, and then they flip-flop, so it's sine of the second, cosine of the first. And I'm sure multiplication community, so maybe it might have written a little bit. Alright, so sine of the first, cosine of the second. And since that's a minus one there, so it's sine of x minus y. Is that correct? So sine of the second, cosine of the first. Looks like cosine of the first. Okay, all of that over. That's why I said y'all get a head start just because this is kind of heavy. Cosine, cosine, opposite sine, sine, sine. That's a plus sign, so cosine, cosine, opposite sine, sine, sine. Okay, I know that was painful, but some sweet stuff happens here. I hope. Okay, across the top, sine of x cosine of y, sine of x cosine of y. So I have two of those that are both positive. Yes, 2 sine of x cosine of y. Now check this out. Sine of y cosine of x, negative sine of y cosine of x. I know it's kind of painful to get to that point, but once you're here, now that you're here, stuff starts to cancel out. I think the same thing's going to happen to the sign. On the bottom, it looks like it's a minus sign and a positive sign, and then I have two of those, so that'll be 2 cosine of x, cosine of y. So we're going to something else that cancels. 2's, and then cosine of y. So then you're left with sine of x over cosine of x, which is tangent. Okay, moving on to the solving one. Actually, solving for trig. These are the two types of factoring. I was about to say, these are the two types of factoring that would be on the test. The GCF, where you're actually going to have like all the terms, and they're going to have something in common, and trinomial factoring. Trinomial factoring being taking an x squared plus blah 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 and breaking up into two factors, like what you've done, like that in algebra 2. So we're going to go through 34 and 35, just so we can see the two different types of factoring. 34 reads like this, as you don't have a book in front of you. Equals 0. Good thing it's already set equal to 0. On your pink sheet, you should have something about factoring, or should have something about solving, where it says, giving one side, factor, separate, solve. I think those are the words we use, factor, separate, solve. Okay, so in terms of factoring, this is the first type of factoring. It's not a trinomial, so we need to look for a GCF. What do you see in terms of a GCF? Sine, yes. So when we take a sine out, I've seen this mistake already this week. We're doing review sheet stuff, which thank you those of you that came and actually work review sheet or ask questions after school. That was cool. But this sign and this sign don't cancel out completely. There's actually a 1 left in its place, so it's 1 minus 2. Now there's another sign left over there equals 0. Once you have it to this point, this is factored. Everybody understands how this is factored? So the GCF factored out. So it's whatever they had in common factored out. Now that it's factored to this point, I'm going to separate. So giving one side, factor, separate, and solve. So to separate, the sine of x equals 0. And then this factor here, I'm going to in my head, I'm moving this plus symbol and adding this, so it's 1 equals 2 sine of x. So I'm really looking for sine of x being equal to a positive 1/2. You can use some good algebra to solve for that. Good things done on that. Alright. how we're on the unit circle of sine, and sine is okay. This one will be 0 and 180. And we're in degrees. Down here and over here, that sine being 1/2. Sine is the y value. Remember, that is the y value, so it's going to be 30 and 150. Yeah, 30 and 150. All right, now. There's a different way I want to show you how to check it in your calculator. I think we've done it a few times, and we'll just check this one and we won't check the next one. But I just wanted to show you a quick checking your calculator. Why don't you go ahead and type in this original equation, so sine of x minus 2 sine of x goes squared. Type that into y1, like into the graphing part, in the graphing part of your calculator. Type that into y1, the graphing part of your calculator. There's still a few left up here if you need a calculator. So I'm typing that directly in my calculator so that I can use my graph. I can use my graph to check it. So running this into negative sine 8 is only going to be 7. So here's how I'm typing in sine of x, and then it says minus 2. And the way you can show that it's squared, because it looks like the only thing that's squared is sine. So minus 2 sine of x was squared. That's how you can show it. It's just the sine of x being squared. There's no need to put parentheses or anything else around all of that. Yes. Sine of x minus 2 sine of x squared. Yeah, because it's not the whole 2 being squared. It's just the sine of x being squared. Now let me adjust my window. What's my domain? What am I allowed to look at here? From 0 to 2 pi. I'm looking around my whole circle. Remember, I'm allowed to solve using my whole circle. All right. I'm just going to change this just for you, so we'll keep it on. Okay, so I can probably just check and make sure that I have enough solutions just by watching it move. Watch this. It crosses out one time. Okay, so we need to, I'm going to do that a little bit more. I'm just watch it draw one more time. How many crosses do I have? I have 1, 2, 3, 4.
Why do you have to?
You can only graph trigonometry in radian mode. Alright, so here we go. Here's how we're going to check it. And our answers were 0, 0, 30. So I'm just going to go through and just check. I'm going to press the trace button and then press 0. That one works. So now we're good. 30, but we're in radian mode, so be careful to type this in. So we got pi over 6. And then pi over 6. That one's good. Was 150. So 5 pi over 6. And then the last one was 180. What is the radian for 180? Good. I'm hoping that one over there is I'm sure it missed another. Yeah, okay. That was right at 2 pi. Right across the 0 to 2 pi, but that's not allowed because we're only allowed to go from 0 to 2 pi with parentheses, 2 pi's in parentheses, so it's not 180. Alright, so that would be like my, just another way to check, if you're looking for another way to check. This is a problem. Alright, and then on to 35, even though that's odd. These are the two kind of ways that you're going to be asked to factor trigonometry. Alright, so this one's a trinomial. So we're going to have to do some sort of trinomial factoring. With trinomial factoring, what I'm talking about is just splitting it up into binomials. It's undistributing, unspoiling, if you will, that's the thing. Alright, so how would you split up a 2 sine squared? One regular sine. Now let's get strategic because we want to be able to multiply and make 2. Then let our outsides and insides make a 5. And which one? So the one with the basic 9 will be a 2. We'll worry about signs over here in closet negatives there. So 2 times 1, that would make 4, and that would make 1. So 4 and 1 is 5. That's good. They're both going to be minus. Very good. So the steps are to factor, separate, then factor, separate. Looks like when I separate that one becomes sine of x equals 1/2. This one becomes sine of x equals 2. So I'm separating them by saying they're both equal to 0, and then solving them for just basic sine of x. Now what you do when you get to this point is you use your unit circle again. We kind of just did this one already. This is 0 versus x is and then where is sine of 2? Okay, so it's outside of the domain in terms of it's outside of the radius of the unit circle only goes from 1 to -1. So for this one to reach out to 2, does not exist. You could does not exist. You could draw the null set. You could just scratch it out. You could write no answer. You can write any of these things to show that answer. And then you're welcome to check this in your calculator the same way where you would type that into the y equals 2. I'm not going to do that on the board, but you can type that into y equals 2, and then just type in pi, because you can only graph in terms of radius, type in pi over 6 and 5 pi over 6. And then on your graph, make sure it only touches twice, because you're only going to want it to cross the x-axis twice if we truly solve for all the solutions. That's another way to check and make sure you got all the correct ones through your graph. Any questions in solving? From 0 to 2 pi. And those steps, make sure you have those steps on your pink sheet. Get everything on one side, factor, separate, solve. That's the procedure for every solving trigonometry. So get everything on one side, factor, separate, solve. That's where you're going to get through all those. Alright, so we got verifying, simplifying, solving equations. We're going to do sum and difference. And that would be it in terms of the sum, like that would be it in terms of those 4, that list we were working off of. Right? Yes. Okay. Alright, so let's do sum and difference identities. We're going to do one sine or cosine, and then we're going to do one tangent limit. I'm just going to have to make that, because the book doesn't have a broad selection of the tangent problems. That's okay. So 52 was asking for sine of 5 pi over 12. Just to draw your attention to the directions. The directions actually said find the exact value. On a quiz or test, a few of you typed this into your calculator, even though you did get the value of sine of 5 pi over 12. You didn't get the exact value because you got a decimal. So just be careful when it says exact value from here on out, whether you're in this class, AP calculus, or in a college course here in the next few years. Whenever it says exact value, that's basically saying in fraction form. Alright, so we need to split up. We're using sum and difference. We split up and figure out ways to multiply to make 5. Add. Add to make 5, and then one of those ways to reduce with 12.
What if you automatically change everything to degrees? Reduce it to 4? You can do this straight.
Yeah, you can change it to degrees, yeah. You can make it straight degrees. Alright, so I've got it to 3 and 2. So hopefully when you reduce it to degrees, let's see, this would end up being pi over 4. And this would end up being pi over 6, which is equivalent to 45 or 30. So y'all got 75 degrees when y'all convert it to degrees, right? Yeah. Okay. And you can split it up using there's 75, we split it up using 45 and 30. Usually the other way to get it, like this is fraction. I would want your fraction. Let's apply the actual pattern. So you have your identity sheet. You have your pink identity sheet in front of you. Most of you do. You have your pink identity sheet in front of you. You're able to read along and follow this. Make sure I'm reading through correctly. The pattern says sine of the first times cosine of the second, and then plus, so it's sine, so sine the same, plus, and then we'll go opposite everything. So we'll do cosine of the first, sine of the second, just so everything gets sine and cosine. Both measurements get sine and cosine. Now let's read our circle. This is where I think maybe we make it more complicated than it has to be. Reading through the problem. On your unit circle, what is sine of pi over 4? Or for your case, what is sine of 45? And then cosine of pi over 6, the x value of pi over 6. Cosine of pi over 4, that's our favorite place in the circle, we know what that is. The sine of pi over 6 is 1/2. That's at 30. It's barely off the x-axis. It's barely up. So sine being y value is a small 1/2. Here's how I want you to write your answers and leave your answers. You could leave your answers in this form here where you put the two fractions together and you multiply fractions, remember pre-algebra, whatever it was we learned, you multiply the tops and you multiply the bottom. So the answer here is actually square root of 6 over 4 plus square root of 2 over 4. And you're welcome to leave it like that, or you can just write it all as one fraction. You may not make it square root of 8 over 4. I'm trying to think of all the little things I see so far. You can't multiply those together and make it square root of 12 over 4. You can't cancel anything out. You can't reduce everything by 2. So don't reduce everything by 2 because it's inside radicals. They're almost stuck. And yes, two fractions being added together, it has to be two things being added together. Is that okay? So, and then we need to make up a tangent. We need to get to that tangent equation. Alright, so for tangent, let's do tangent of tangent of 165. I think how did you make 165? 120 plus 45, very good. Alright, so tangent is going to be 120 plus 45. At this point, I take a side note just because maybe most of the smaller mistakes that I saw through these problems was actually just finding the tangent of these things. So let's go through and actually figure out what is the tangent of 120. What is the tangent of 45? That's our favorite place in the circle. The tangent of 45 is 1. So let's figure out what is the tangent of 120. When I count over to 120, I'm putting sine over cosine. Let's be careful of our negative sign as well. At 120. The sine, yeah, the sine is the bigger one. And the cosine is on the left. That's it. Negative 1/2. Or I'm just going to write negative square root of 3. So tangent of 120, I'm just going to write negative square root of 3 just because the denominators, the 2 and 2, and the denominators you cancel out. You're allowed to cancel out denominators. You wouldn't be allowed to cancel out numerators. You'd be allowed to cancel out denominators to have the same thing. And then that negative sign. Alright, so let's fill in the pattern. The pattern says, and you have a time sheet in front of you, the tangent of the first plus tangent of the second. So tangent of the first, so negative square root of 3, plus tangent of the second, which is 1. And you multiply those, so 1 minus tangent of the first times tangent of the second. And you multiply those together, it's just negative square root of 3. Alright, let's rewrite this. I like to write this a little bit neater. I like to write it in standard form where the numbers come first, the radical expression comes next. You don't really have to do that, but that's just a good habit to get into because it's easier to see the conjugate later on. And everybody knows I'm not a conjugate. So what I'm talking about in standard form is writing the number first, radical form later, or radical form second, so plus square root of 3. All right. Sometimes you'll have an issue where it's like you'll have an instance where it's the tangent, like that actual square root of 3 term, will be a square root of 3 over 3. That's what yours is at the end?
Yeah,
okay. What I would do at this point here, if I had, let's take a little sidebar here. If I had that, I don't know what the numbers might be, but all the patterns would be the same. At this point here, I multiply top and bottom by 3 just to get rid of the denominator altogether and make it say this. So instead of your conjugate being 1 minus square root of 3, your conjugate would be 3 minus square root of 3. So that would be, if you had a double fraction thing happening, that would be how I would take care of the double fraction thing. Again, we're just trying to make these things like you're just trying to make it, if it's a double fraction, just trying to make it easier on you. Get rid of that fraction, unless you're cool with it. But just to avoid small arithmetic mistakes, I would get rid of the fractions as soon as it. Okay, so what's our algebra issue now? Radical in the denominator. To get rid of the radical in the denominator, I used that word conjugate earlier. This is what the word conjugate means. The conjugate to 1 plus square root of 3 would be 1 minus square root of 3. What this does is it reduces out the radical term in the bottom. We're using this skill from Algebra 2 to simplify this tangent expression so that we have no radicals on the bottom of the fraction, no radicals in the denominator. We can get an exact answer, an algebra appropriate exact answer for this expression. I'm going to basically distribute across the top the 1 to 1, negative square root of 3, negative square root of 3, I'm going to write negative 2 square root of 3. You're welcome to write out all the steps of the binomial distribution if you need to. Negative square root of 3 times negative, that's a plus 3. Now, top to bottom, the reason we use the conjugate is because the radicals just cancel out, so I'm just going to multiply the front and the 1 to 1, 1 to 3, and 3 to 1. Those are canceled, and then negative 3 will come out of that radical there. I'm going to leave my answer as this. 1 plus 3, so 4 minus 2 square root of 3 all over 1 minus 3, negative 2. You may leave your answer that way, or you could write it as negative 2 plus square root of 3. Did you got it?
Yes.
Awesome. Good job. Questions here? Anything can help you on this? Angela, this is the most complicated sum and difference I did any, honestly. Just because it requires so much algebra to get the right answer. It's still a plug and chug formula, but you have to do so much algebra to get to the right answer.